morning. We're down in the shop today working on a new product design idea. It's actually a lead head jig design that I've been working on for a while, but now I've decided to refine it a bit more and add a little bit more detail to it. So today we got to make a test mold, which is a little one cavity mold that's going to allow us to put some hooks in and pour some lead, make sure everything fits right and all the dimensions look good, and even go fish it a little bit. So right now I got getting everything lined up. And the MR1 is all fired up and warmed up, ready to go. And we can go through cutting the mold. So let me go show you the Fusion 360 side of things first.
Alright guys, so here we are back in Fusion. This is the jig that we're going to be building a test mold for today. We're just going to build a little single cavity test mold. Something that I can put a hook in, pour, make sure everything looks good, check dimensions, even make a few to go fish. So this is one of my, we always call it a current cutter. As you can see, it's got an angled head, so it'll move through the river current. I tend to use this vertical jigging in the winter and the spring for sauger. Been using it in the as a hair jig as well in the summer and the winter. And the only difference is I've been fishing it without that 3D eye socket. I just think it'd be something, I want to add something to it. So I think that putting a 3D eye socket in there would look pretty cool. So let's give it a shot. So I have the mold all designed here. You can see it's just a negative of the model we looked at earlier. I got the sprue up top, good size opening. I can flip on this and I show you what it's going to look like when it's all together. You can notice the sprue is kind of at an offset. That's just the way I had the jig turn. I'm trying to see if I can make it so that the sprue is easier to break off, once you pull the jig out of the mold. And then it's going to be held together with a couple 1/4-inch bolts, a couple wing nuts. We got the hook slot and everything, so you can drop a hook right in here, close it up, and pour. So pretty simple. We can pull up the cam. Alright, let's step through the simulation. So we're going to start off with a 1/2 inch roughing end mill that's going to rough out both sides, and it's going to make the first facing pass. I leave 4/1000ths on top of each piece with the facing pass so I'd come through with the fly cutter and get a smooth finish. Next we're going to switch to a half inch end mill that's smooth, and we're going to clean up the outside and we're going to cut the pocket for the hooks. Finally, we'll come through with the fly cutter and clean up that top surface and take that extra 4/1000ths off. The fly cutter gives a very smooth surface, which is very important when you're making a mold. You want both halves to seal up perfectly so you don't get flashing on your jig, which is the little lead pieces that'll hang off the edges. The less of that you have, the quicker you can make them, and the less time you have in production. So it's very important to do this step. Alright, finally, time to start cutting the cavities. So we're going to come in with an 1/8 inch end mill, and it's going to hog out most of the material and get the cavity ready for the detail work. Now we're going to switch to a 1/16 ball end mill, and that's going to come in and do all the detail work. Alright, we're almost there. I know I got it going fast, but the last thing you want to do is watch a computer screen. So we're going to flip to a 1/16 inch flat end mill, and this is going to cut the slots for all the eyes of the hook. Finally, we're going to come in with our 32nd inch end mill, and that's going to clean up the little slots there for the hook to sit in. I didn't program this the best, that's why it's hopping back and forth. Finally, we're going to bore the holes for the pins to line up. It's going to make its bore pass, and it's going to make, I believe, 3 contour passes to get to our final OD. Once that's all said and done, if we do everything right, this should be what we're left with. And then we'll just have to flip it over and cut this little cap off in the machine. And then we'll have 2 separate pieces. So let's go get some stock load in the machine and start making some chips.
Now we got that figured out. Time to get the machine ready to take stock. As you can see, it's been a busy few days here, so just to make sure I got everything right, I'm going to clean up a little bit and make sure we're ready to go.
Now you've watched me push chips around the machine for a while. I should have cleaned them up, obviously, but in this case I was more worried about just making a pathway for the coolant to make it back to the drains. We're going to go ahead and load the aluminum. I got 2 parallels set up inside the vise there. Tighten it down. As you notice, I run my vise backwards, and this is because I like the sprue edge of the mold to be against the fixed jaw of the vise. But I also like to be able to monitor those sprues as they're being cut so I'm not cutting down into my vise. It's happened before, and this just allows me to keep an eye on things and make sure that it's not going crazy on me, which it has before. We're going to follow this up with a hammer. We're going to give the aluminum a couple good hits on each side just to make sure that the piece is fully down on the parallels so that they're not moving. Of course, when I got the cameras running, that's when things want to give me a fit. As you can see, I kind of keep fighting trying to set the parallels. The first one set, and then usually the second one doesn't set, and you keep going back and forth. So finally I got it. They locked in. We're down on the parallels. Life is good. Now to continue with the fun, tedious setup of this project, we're going to probe the stock into the software. So what we're doing is we're going to set a 0 point on the stock for our G-code to reference while it makes its cuts. I like to set my 0 point right in the dead center of the stock. Touching off on all 4 edges of the stock is what's going to allow me to use the software within the CNC machine to calculate where the center point of that stock is going to be. Finally, we're going to probe the top of the stock, and then we're going to use that to set our tool setter, which is sitting just off to the right there. This will allow us to make tool changes throughout the process and keep the same reference point for height. Now we've got our first program loaded up. The stock is in. It is set to 0. It's time to finally get this thing going. I got the camera set up here. We're going to see how this works. Starting off here, we're going to start with a 1/2 inch roughing end mill, and this is going to do the majority of the shaping for the outside of the two pieces. I know what you're thinking. I got to get lights in this machine, so that'll be the next project for the next video. Unfortunately, the coolant is kind of a necessary evil. It messes with the camera, but with the way we're cutting this and so aggressively, it's required. Otherwise, we might have a big mess on our hands as far as broken end mills and whatnot. Now we've switched to a regular 1/2 inch end mill. Due to operator error, I missed the part where it went around the outside and cleaned up the outside faces of each side, but now it's cutting the pockets of each for where the hooks are going to sit. Last but not least for these initial steps is the fly cutter, and this is what's going to give us an ultra smooth surface for putting the cavity on. You see, we got a nice smooth surface for the cavity. Hook pockets right here. Screw's going to be right here on each side. We're on our way. So now it's time to start the cavity, and the reason I'm laughing is because I tried something here where it would make it easier for you guys to see it. Obviously the coolant's off, but I don't have a compressed air system on this machine like I probably should. So when I turned the coolant off, the chips started building up, and it was blocking the view anyway. So the other problem is I also went too aggressive with this program, and as you're going to see in a minute, the machine taught me really quick it was too aggressive. And we have failure. So I got a new tool loaded up, and I went back to the programming in Fusion, and I backed things off a little bit so it wouldn't be taking such a big bite. Obviously left the coolant on, and this time we were able to get through. This is after the eighth inch end mill pass. We're going to put the 16th in now. Now we're getting down to what I would call the meat and potatoes of this build. So because of the size of this jig, the 16th inch end mill, the ball end mill, is going to do the majority of our finishing. So we're getting down to the detail work. The 16th inch end mill is going to go in and it's going to finish removing material that the 1/8 inch couldn't get to, and then it's going to follow that up with a very small, we call it a scallop pass. And what that's going to do is it's going to basically go in and smooth things out and remove any of the little imperfections. You'll get some tool lines and whatnot, but that's not that big a deal. The lead won't pick that up, and if you powder coat it anyway, you're not going to see anything. So but yeah, this is definitely by far our longest operation. I think it ended up being an hour 23 when it was all said and done. Here you can see we've moved into that scallop pass. The movements aren't so jerky and it's not picking up as much anymore. It's just following along the contours of that cavity and cleaning everything up. I typically do the cavities and the sprues separately. That's just because I use the same type of cam operation and fusion to do each one, but I have different settings so that I can get the same result that I want. I figured this was as safe a spot as any to turn the coolant off and allow you guys to see a little better what it's doing. You can see it's just running up and down that contour, moving in a little bit, and just taking a little bit of material off each time. We're getting there. A few more steps. So now the major cavity work is done, so now it's time to make space for the hook. So we're going to start off with a 16th inch flat end mill, and that's going to go ahead and cut out the round pocket for the eye of the hook. And then we're going to drop down to a 1/32 ball end mill to cut the slot for the wire of the hook. The key with these tiny end mills is speed. If you push them too fast, they're going to break in a heartbeat. So I have these clips sped up, obviously, because no one wants to sit here and watch this in real time. Even I didn't. But you definitely got to slow way down, and you just kind of got to take little cuts at a time, and eventually you'll have your slot for your hook. There we go, we got the slots in there for the hook. Should be able now just to take a hook. Oop. There we go. Fits perfect right in there. Pick it up. The other side. There we go. Alright, let's bore the holes and finish her up. Now admittedly the better way to do this would be to run a drill bit down in there to the proper depth, then come back in with the boring operation, open the holes up, but I just kind of found a process I like that works for me, and this is what I've stuck with. I'm definitely not a professional machinist. I'm all self-taught, so this is all just kind of ways I've learned to do it myself. So what I do is I bore it and then I come back in with a contour operation to open up the holes to fit the dowel. Alright, I had to open them up a little bit more than I thought I would, but this is just a 1/4 inch dowel rod, but it fits in, without not much play. Alright, so that side's done. We'll flip it over. Now it's time to flip it, grip it, and rip it. We went and pulled the mold out of the vise and flipped it over, and now we're going to cut that cap off the back, and once that's done we'll have 2 individual pieces and a finished mold. Here's our final product. 2 individual pieces, 2 sides. Let's do a test fit. You see both bolts are in there. The hook sits in there nice. We're going to close it up. And we're going to do a quick check. Make sure the edges all look closed up. Make sure the screws lined up. And this one looks like it's ready to go. Let's do a test pour real quick. See if we get what we're looking for here. I probably should have glasses on, I know. Mold poured really nice. When the lead drops in, it just keeps flowing. You know you did good there. There we go, a good solid pour. Ended up pouring a few of these just to see, and they had good repeatability, and everything turned out nice.
So if you guys stuck around this long, I appreciate you. Hope that was a bit interesting. I'll keep doing more of these if you guys are interested, and we can keep building molds on these YouTube videos, and I can keep sharing the process. So thanks for watching.